Good morning to all. Myself, Dr. Arun again here from Aerospace Engineering Department. Today, I am going to take one topic from Fundamentals of Aerospace Engineering subject for first year students. So, if the topic name is Basics of Aircraft Power Plants. So, this is the fourth unit. So, in that slide, it is a mind map for Unit 4. That means a glimpse of Unit 4. So in that Unit 4, we are going to study about the types of engines, types of rocket propulsion. So in that types of engines, it can be classified into turboshaft, uh, turboprop, and piston engine and jet engines. In that rocket engine, it can be classified as the solid propellant, liquid propellant, and hybrid propellant engines. So in that topic, it can be uh, classified into five stages of DT. First one is empathize. So in that empathize the why propulsion matters. So in that propulsion, it is a heart of the flight. So in that propulsion means it is a forward force. It can be created by the Newton's third law. That means every action is an equivalent opposite reaction. So in that cases, the Newton's third law, it can be used to generate the thrust. Next one is the defined stages. So in that defined stages, what are all the requirements it can be used for the power plant? First one is power. So in that power, it can be deliver the thrust for the takeoff, cruise, and maneuvering phases. Maneuvering means the takeoff uh, and landing. These are all the maneuvering path. Next one is power to weight optimization. So in that cases, the how much of weight it can be carried for particular power. For example, if I using the one bike, if the CC is 150 cc, so in that cases the maximum capacity uh, of this bike is around 180 kg. So if you use beyond 180 kg means the if the bike pulling power it will be drastically reduced. That is called as the power to weight optimization. Neg- Next one is fuel efficiency and reliability. So then the fuel efficiency it can be a major component for the flight optimization. So the how much of fuel it can be used for travel the particular distance. That is called as the fuel efficiency. Next one is a mission specific adaptation. So in that cases, we have to check the endurance, speed, and altitude. Next one is in that ideate part and what are the types of reciprocating to jet engine propulsions we are using. First one is the reciprocating engine. So in that reciprocating engines, the here that is called as a piston engine. It can be run by the piston movement. So in that piston movement, it can be create the mechanical power with the help of the chemical energy. Next one is the gas turbine engine. So in that gas turbine engine, the whole the part it can be connected in that shaft only. So it can be classified into turbojet, turbofan, turboprop, and turboshaft. These are all the types of gas turbine engine. Next one is a rocket engine. So in that rocket engine, oxidizer and fuel it can be carried in the separate tank. Mixes of this, the burning will happen. Next one is that reciprocating engines. The here we can use the cylinder configuration. So in that cylinder configuration, it can be classified into four types. So first one is the radial arrangement. Next one is the inline arrangements, and third one is the V-type engine. In that V-type of engine, it can be used for the higher end vehicles like BMW, Rolls-Royce. These are all the vehicle. Uh, Generally, the V-type of engines can be used today. And next one is the gas turbine engine powering modern high. So in that gas turbine engine, already I told you that it can be classified into four types. First one is a turbojet engine. It directly it gives the thrust with the help of high velocity exhaust. In that turbofan engine, they have used for the fan. So in that fan, it can be produce the uh, more amount of thrust compared to the turbojet engines. And next one is a turboprop engine, that is called as a helicopter engine. So in that cases, the propeller it can be connected to the engine with the help of the shaft. Next one is a turboshaft engine. This is the in that cases it can be used to generate the more amount of mechanical power. Next one is the engine selection factor, that is called as a prototype stage. So in that engine selection, what are the cases we need to check? First one is a aircraft training. So in that cases, the maintenance and power delivery, these are all things it can be used for this aero training. Next one is a fighter aircraft. So in that fighter aircraft, we will use it for the supersonic capacity engines and high thrust to weight ratio engines. So next in that for I'm taking the case study like passenger aircraft versus fighter jet aircraft. So in that passenger aircraft, we have used for the turboprop engine. If I using the fighter jet aircraft, we have used it for the turbofan engines. So the two turbofan engines can be used for that fighter jet aircraft. So in that passenger aircraft, it have a subsonic speed only. In that fighter aircraft, it can be a supersonic speed. So thank you. So we will catch you on next topic on next video.